The Modern Language Association provides listening tests to measure understanding of speaking French. The range of scores is 0 to 46. Here are scores of 21 high school French teachers at the beginning of an intensive summer course in French. They're already in order for us, so that makes it nice. I want to make a stem and leaf plot. So we're going to make the stem part, put our line, and make our leaf. And like they said, the stem is everything but the very last digit. Now notice 9 only has one digit, so I'm going to add a 0 in front of it so that we know it has kind of the 2 digits to give it a stem portion. So we're going to need a 0 for a stem. 15 tells me I need a 1 for a stem. All the 20s need a 2 for its stem. The 30s need a 3. And the 40s need a 4. Now I'm going to take the second digit and kind of stack them up in order as we go out. So 0 only has 9, so its leaf is 9. 1 only has 5. Now the 20s, we're going to start stacking them as we go out, and we want to include the repeats. So we have 2 20s, which means we have 2 zeros for those leaves. And then we have a 2. We have 2 3s because of the 23s, 2 4s because of 24, a 25, and a 29. And we don't put commas in between them, but if someone looks at a stem and leaf plot, they're supposed to be able to recognize that each one of the numbers in the leaves represents a 2-digit number in this case. So they're not just one big long number. All right, we're going to do the same thing for the 30s. So we have 2 30s, so we need 2 zeros. 2 31s, so 2 1s, and a 2. And for 40, we need a 0. We need 2 4s, a 5, and a 6. Questions on that? So we should be able to get back to those lists of numbers if we wanted to from this table. It's just kind of a condensed way to combine them. And it's a kind of a way of looking almost at a frequency count, breaking it up by that first stem number, and then saying, okay, well, what does the distribution kind of look like? I know it's on its side, but I'm going to pretend and put a bell curve over the top of it. And we can get an idea of kind of the shape. Just from those numbers, would we say, based on our criteria from yesterday, would we say this looks normal? Well, it doesn't really look symmetrical, right? Because we don't have a nice set of, 5 numbers on the upper side of our maximum amount. So it looks kind of like, kind of skewed right, yeah. I mean, we don't have a lot of numbers, but it looks a little skewed right. So it's just kind of a nice way to kind of group the information quickly if you have a small data set. So, and we already kind of answered the second part. We want to describe the shape of this. We would say skewed right. And you kind of have to think about, actually, if I turned it, I can't really turn it. The smaller numbers would be kind of the direction we're tailing off to. So is that right or is that left? Or negative and positive skewed? That's a negative, so it's actually my left. If you look at it the other way, because the peak is more towards the upper numbers. At least we know it's not symmetric, which is the main thing that we want or we're looking for in these particular pieces. Are there questions on that? All right, so we can also use this to compare two groups of things or two people. So this data shows the points scored by two high school basketball teams in their last 10 games. Make a back-to-back stem and leaf plot. So if they're back-to-back, it gives me a chance to kind of compare them a little bit more. So I'm going to put my team A, and I'm going to say I've got my stem in the middle this time, and we'll put our team B. So these numbers range from 70 to 90. So what do we need for our stem numbers? 7, 8, and a 9. And for team A, we're going to actually write the numbers the opposite direction. So you're going to put the smallest one closest to the stem and then move out with the larger numbers. And then team B will look like the one above where we continue out the way we did before. So for team A, we have a 70, so we need a 0, then we need a 2, a 4, and a 6. Then we need a 1, a 3, and a 5. And we need 0, 5, and 5. Now we'll do the same thing on the other side, but going the opposite direction. So we've got a 2, 5, 6, and 7. 3, 5, and 6. 0, 4, and 4. Questions on that?
What does this tell you?
This kind of gives me a chance to see, I can compare the teams, and if you compare their wins or their points scored, what would we say about them? They're pretty comparable, right? So it just kind of gives us a condensed way to look at their scores and say, well, they're both have 4 games that are in the 70 range, 3 games in the 80 range, and 3 games in the 90 range. So just kind of a quick way to compare the two teams. Other than that, it doesn't really tell me a whole lot. It tells me that it's pretty uniformed as far as the shape goes, right? They're saying pretty even throughout. I wouldn't necessarily say this is unimodal or skewed one way or the other. It's all kind of just uniforms, kind of symmetric, but not necessarily a bell-shaped symmetric. Other questions? They're a lot easier than our histograms and frequency distributions. All right. So one last back-to-back plot. These ones are already created, and we can use computers to help us create them. In this plot, we want to look at the weights put together, and then they kind of separated them. So they're looking at, I believe, the weight loss in this case, or the weights of college students. And in our first STEM plot, all they did is they put all the students together. And if we look at just that one, it's not a back-to-back plot, it's just everybody together. And notice that these had 3 digits. And the computer doesn't necessarily draw it in, but I'm going to put it in just so we know. The vertical line would be in between there. So those 2 digits in front are my stem. So the 10 is actually all of my stem, which tells me that if I was to try to put these numbers back together for this first group, I'd have a 101, 108, and another 108. So even though there's multiple digits in the front, that's fine. It just tells me there's more pieces to my stem. And then the numbers separated on the other side still represent just your last digit. So if you end up with data that's more than just two digits, we kind of know what to do with those as we go out. But what we really want to do is we want to look at this and we want to say, what do we notice between the difference in our 2 distributions? So we have the 1 with everyone together, and then they split up the weights dependent on gender. So they did males and females. So if you compare these 2 stem and leaf plots, what do you notice about them? The females seem to be lighter. The men are on the heavier end. But if you compare the one where they're grouped together, what would you say about its shape? It's what? Well, let's see. If I overlay a curve on this one, looks like it's a little bit multimodal or maybe even just bimodal. If we kind of came over here, these ones are looking a little bit different. They look more unimodal, right? So when all the data is together, we get a bimodal model. But when you separate, each group is unimodal. Which kind of makes sense that the group's data would be bimodal, right? If each of the two of them is giving me a unimodal model, when you put them together, we're getting the two peaks, which give us our bimodal model, where we have the peak for our women's weights and then the peaks for the men's weights in there. Questions on that? All right, if we just look at the males and females, what do we notice about those two? Any specifics between their two shapes?
I feel like the female is more bell shape, whereas the guys looks more left.
It looks skewed, right?
Yeah.
So the women look approximately normal and symmetric, whereas the men are skewed. Now, if we think about it, it's tailing off towards the larger number. So is it left skewed or right skewed? Right skewed, right? Because right goes with our positive numbers. I kind of think about you tail off in the direction that you're pointing. I have to still use my arms so I know which way I'm going. All right, so the women are bell-shaped. Or we can say symmetric. And the men are skewed, right? Or if you want to think about it as a positively skewed distribution. Other questions on that?